Okay, so what we need to understand is how to get inverse functions. Let's have a brief recap of what a function does. Here we have a function which reads f of x equals 2x plus 1. Remember, looking at it in a silly way, that means if we give the function, let's say, an apple, then what will we get out? We'll get 2 apples plus 1. So whatever you put into the function, you get 2 of those things back out plus 1. It takes whatever you give it, it doubles it and adds 1. Okay, so that function can be represented in this way. You can suggest that x goes into the function, you times it by 2, and you add 1, and you end up with 2x plus 1. Now an inverse function is to go the reverse way. So if that's done in the opposite direction, what will happen when we give it x? Well, we'll do the opposite of what we've got here, which will be to subtract 1. We then put that function into here, and we would divide by 2. So that means we'd end up with x subtract 1 divided by 2. That would be the inverse function. Now the inverse function isn't written with an I, it's written in this way. And that's not to be confused in any way with that. Temptation might be to think that that means 1 over. That would be wrong. That is not the case. So what it actually means is it's the function that goes the opposite way to f of x, and in this case it will be x subtract 1 divided by 2. So this is the inverse function to this. Okay, so let's have a look at another function we could try from that. We tried a function g of x is equal to a half x minus 2, then that function we could write as a half x multiplied by a half, and then subtract 2, and that would give us a half x minus 2. So the details of what's happening is that after the first stage you get a half x, and then you subtract 2 to get the half x minus 2. So what would the inverse function look like in that case? So we could reverse it and say, okay, if we give the function back the other way, what's the first thing we do with x if we're going the opposite way? Well, we would add 2, and then we would end up with dividing by a half, and we'd get our answer out here. So our function would be x add 2, and then after having added the 2 we would divide it by a half. So our inverse function would be written this way, and it would read x add 2 divided by a half. We never leave that. We know that when we divide by a half, we actually write it as x add 2, and the half is turned upside down and multiplied. So in this case we end up with 2 lots of x add 2. So that becomes our inverse function. Okay, it's important that we appreciate what takes place first. A common mistake could happen here. A common mistake is that many students might look at this function here, if I shade in the one I'm talking about, and they may say, okay, when I put that in here, does it make any difference? Could I subtract the 2 first? Remember, that would be a disaster, because if you subtracted the 2 first, you'd get a different function. Once you'd subtracted the 2 in this box, you'd end up with a subtract 2 would be here x subtract 2, and then of course you'd do the multiply by a half, so here you'd end up with x subtract 2 and multiplied by a half is a different answer to the original one. So be careful. It's important to notice here your multiplication took place first because there's no bracket, the subtraction took place second. Okay, now if you follow using those boxes, that might be one way of getting the inverse. But there has to be a foolproof way of doing it where there will be no mistakes, and it's a very good method for practicing another topic you've already done, and that is change of subject. So let's find the inverse of f of x equals 2x plus 1, and this time use a different method to do it. So we're going to use f of x equals 2x plus 1. Now the great thing about this is we already know the answer is going to be f inverse of x will be equal to x take 1 divided by 2. But this foolproof method, if you follow it exactly, will work every time. Instead of f of x, let's write y equals 2x plus 1. The first job you have to do is to change the y into an x and the x into a y. And now it's the change of subject formulas that you've used so many times before. Now I'm going to show how to solve this using the balancing technique, but I want to make y the subject. I think I need to get rid of the plus 1 first of all. So using the balancing technique, I'm going to subtract 1 from both sides. I'm going to show that by subtracting 1 on both sides. I now simplify my answer, and it reads x take 1 on the left hand side equals 2y on the right hand side. Both of these have cancelled. I now need to get what y is. So I'm going to divide both sides by, by 2. And now move it up a little bit, and now of course these will cancel, and I'll be left with y equals x minus 1 over 2, i.e. the inverse function of x equals x minus 1 over 2. So it's a foolproof way for how to get these to work. Great method, always works. Let's just make sure we prove it always works. Let's have a go back and have a look at the function g. If you remember, that function g was a half x minus 2. And we know what its inverse should be. Let's go and prove that it works on that method. So we have a function g of x equals a half x, and our function for g was half x take away 2. So we'll bring that back up. A half x take away 2, and we now need to find the inverse. What's the first thing we do? Correct. We turn g of x into y equals a half x take 2. The second thing, turn the y into an x and turn the x into a y. The next thing, change the subject to make it y equals. First thing I want to do is to get rid of the minus 2, so I'm going to use the balance technique to do that, which means I'm going to add 2 to both sides of my equation. Of course, I expect a little bit of cancelling from that. Those 2 will cancel, so I'm left with a half y equals x plus 2. I'll move my paper down. I need to get rid of the half. Well, it's a half multiplied by y, so yes indeed, the opposite of multiplied by a half is going to be divide by a half. Remember, everything on both sides of the equation has to be divided by the half. If I'm going to be consistent in what I'm telling you, of course, that means I'm going to write that in red ink. And of course I divide both sides of the equation by a half. Those 2 halves will cancel, so I'm left with y on the right hand side, and I'm now left with x plus 2 over a half. You may remember before I said we never leave it divide by a half, so now it's going to read y equals x plus 2, and I want it multiplied by 2 over 1, So I'm going to put brackets around that. If you don't, you're going to have a problem because you're only going to end up multiplying just the x by the 2. So I'm multiplying by 2 over 1, and of course 2 over 1 is the same as 2. So there's my function. And of course that means g inverse of x equals 2x plus 2. So that foolproof method is described in the section on inverse functions, and you need to practice it. Very good stuff, because it not only teaches you how to find inverse functions, but it revises your methods of finding change of subject formulas. Could kill two birds, or more importantly 2 questions, with one stone.